Hi guys, so welcome to part 2 of my deep cleaning video for my Cardline custom water cooling loop for my PC. So Realm, I'm going to show you videos of where I deep clean my CPU block. So obviously you need the GPU block to cool down the GPU, but you also need the CPU block to cool down your CPU. So yeah, it still has liquid metal on it, and then I disassembled the let me just speed it up to maybe like 5x speed. Yep. So they come with, this is a Biski CPU water block for AM5 and AM4, and they come with what you call it, hexagonal screws, and you can see the sediments there as well. So there's still corrosion in the system, and then the metal sediments kind of like will gather inside the cold plate in the fins. So I brush it using some dishwashing liquid, clean it up, and then we reinstall back the rubber seal. Try to clean away that there's some discoloration in the nickel plated aluminium, I believe, but can't really remove it. So I think I've got to use some polishing liquid to remove it. I tried to remove it using isopropyl alcohol here, but not much luck. So just leave it as it is. Make sure the rubber seal sits in properly into the grooves, if not you'll get leaks. Then I clean the acrylic part as well. And reassemble the CPU block. Okay, so there's that. Next one, this is cleaning. Okay, so I reassembled the GPU block again because I kind of noticed that there's some impurities and some dirt inside the metal part. So I kind of had to clean it up and reassemble it the second time. And reassembling the GPU block is not really that tricky, it's not that difficult, but make sure that the rubber seal is in there. So make sure the rubber seal is seated in there. Right. If the rubber seal kind of runs out, then obviously you will not have a good seal with the acrylic and the nickel plated aluminium block. Then that would create a leak. So same is using some hexagonal screws as well. So make sure you have the appropriate bit size. So I'm just going to fast forward it. Make sure I do the cross tightening method as well to make sure that all the screws sit in evenly. So I cross tighten the screws, go in a diagonal shape. And so I should do it the second time because I noticed that there's impurities there. So I think this is the part where I noticed there's some impurity here, some dirt here. Then remove it with isopropyl alcohol. Right, and then I screw it in again. Yep, basically you don't want to have any like dirt particles or anything that's dirty inside your loop, because your loop is gonna have to stay there for like half a year, or sometimes even like 2 to 5 years for some people who don't drain or change the water in their loop, or they don't deep clean their loop. So you really want your loop to be as clean as possible. Okay, then next one here, cleaning the liquid metal from CPU and GPU water block. Okay, so in this case, I think this is the 7800X3D CPU, and I'm reapplying the nail varnish to insulate the surrounding SMDs there, because I noticed that I think the coverage wasn't ideal. So now I'm going through the process of removing the old liquid metal from the CPU IHS. IHS meaning the integrated heat spreader. So in this fast forward process, you can see it's pretty satisfying. So basically you spray a little bit of isopropyl alcohol on the clean cotton bud, and then using the cotton bud you try and absorb basically try to absorb the liquid metal into the cotton bud. Then you can see that as it absorbs, it looks black. So fast forward more, I have to go through several cotton buds actually. Now you can see a little bit of the rise in words. I don't know if there's corrosion in the IHS. I think there might be a little bit because I don't think I cleaned it fully. Like as much as I try to get it clean, yeah, I think as clean as I could get it. I didn't get it clean that much because I'm gonna reapply a second layer of liquid metal as well. Then now I'm cleaning the liquid metal away from the cold plate part of the CPU block, and you can see there's some darkened parts even though it's nickel plated aluminium. I think it went through the nickel plate and it has some corrosion on it, I believe. Yeah, so some corrosion after the nickel plate, but it should still be fine. Like the temps were still okay even after reassembly. As long as the corrosion doesn't go through the whole aluminium, I think it's usually fine. Right, so here I reapply the liquid metal. So if you're concerned about how to get this thing to smoothen out, usually in this case, because corrosion and chemical reactions has occurred in the liquid metal part, you actually have to sand it down. That's what I saw from some of the guides online, where some people actually do liquid metal for their laptops. So for their laptops, they do liquid metal. Then usually those laptop heat spreaders are made of copper. So there's chemical reaction and yeah, slight bonding as well with the liquid metal and the plate. Sorry, liquid metal and the copper. So let me use a different software to open this up. Maybe this one. Or maybe Movie Maker. Media player. Let's see whether I can rotate. Oh yeah, I can rotate video here. Okay. Alright, so in this case, I'm reapplying the liquid metal. And so you've seen quite a few of my videos. If you've been a regular viewer, you've known that I do a lot of liquid metal videos. So the gist of it is you apply a little bit of liquid metal, like a fraction of a drop, and then try to spread it out as thinly as possible, right? As thinly as evenly as possible. And if it's not enough to spread, then you add just a pinch more liquid metal. But you really want to be really frugal with a liquid metal application, because the dangers of liquid metal is that if it's too much, it might cause spillage when you move the component around. And especially that the components are not going to be lying horizontal, they're going to be lying vertical most of the time, because your CPU and your motherboard is usually in the vertical orientation. So you gotta make sure that the liquid metal spread is thin enough that it doesn't gather into a pool and then drip onto your components below. So it has to be thin, so that the surface tension of the thin amount of liquid metal on the CPU IHS and the cold plate is gonna like bond them together, and that is gonna prevent spillage. So the secret to preventing spillage is make sure that the application is thin enough. But the challenge is that it is thin enough, but still ensure that you have an even coverage to avoid hot spots. So you want to make sure that the liquid metal covers every single spot on your IHS and your cold plate. So I'm gonna just fast forward through, so that is you can see that I'm covering as much as I can. There isn't much contact with the CPU IHS in the corners of the AM5 IHS. But I just like to, a little bit paranoid. I just want to ensure that I have as much coverage as possible. So you can see here, look at the coverage is pretty even. There's everything is white. You can see silver, so you don't see any obvious empty spots there. So I do the same with the CPU IHS. So in this case, I add a little bit more, then spread it out. So you spread out thinly with a cotton bud, and for the areas where there is a little bit of empty spots, you use a little dabbing method to try and dab, because the liquid metal will actually accumulate on the tip of your cotton bud, as you can see here. So until your cotton bud, you will accumulate. let's use a big pen. Okay, so you can see the liquid metal accumulates on the tip of the cotton buds here. So you can use the accumulated liquid metal and use like a dabbing motion, and you just dab on the spots. Like let's say there's a spot here, there's a spot here. You just use a dabbing motion to dab on those spots to ensure that the liquid metal like applies to those specific areas. Okay, so there's that. So liquid metal applied. Then okay, so this one I didn't really record it, but basically I already placed my 7800X3D back into my motherboard slot, which is on my height Y60 case. Then now I install back the CPU block, place the CPU block on it, and then the screws are actually thumb screws. So for the Biskey CPU water block, I think quite a few of their CPU water blocks. The installation is pretty straightforward. For AM5, they're using the existing motherboard backplate because the motherboard backplate is screwed into the motherboards on AM5 motherboards. So you just need to align the CPU water block holes with the right screw holes, and then thread the thumb screws in. So in this case, the thumb screws has a washer and spring. The washer and spring helps to ensure there's sufficient pressure on the cold plate. Yep. For this motherboard, I always had an issue with the SSD heatsink. Like the primary SSD heatsink kind of like sits under the CPU water block, because the CPU water block is a little bit on the larger end. So I always wondered if it interfered with my pressure as I screwed down on it. So far I think it's fine, but it's always on the back of my mind for this particular motherboard. So the motherboard I'm using is the Aorus, the X670 Aorus Elite Wi-Fi AX. Yeah, I believe that's the name. Is a mouthful, but I just remember there's a Gigabyte Aorus Elite. Then it's the X670 variant. So yeah, so if you are using a big CPU water block like this, kindly note that there might be interference. So like a smaller CPU water block for water cooling might be better. You might get less fin area, but you might have less problems with interference that comes from the SSD heatsink. And as you know, in modern day, like even for Gen 4 drives, SSD heatsinks are pretty much essential. So I can't really like take out the SSD heatsink here because I do have a Gen 4 drive installed in the primary slot. And if you're going with a Gen 5 SSD, the heatsink is even more essential. Okay, so that's done. So next up, we're to screw in the top radiator. So in the previous part, I actually showed that I installed the top radiator, but I haven't screwed it in. So the top radiator comes with screws, which are like there's one here, and one here, and I believe here and here. There's, I believe, about 6 to 7 screws. Yeah, so I think there's at least 6 screws. One here, here, and here. So this is the installation screws for the height Y60 top radiator bracket. I do like this case though. It is pretty radiator friendly because they have this bracket that you can take out. Then you take out the bracket, you install your AR radiator or your custom water cooling radiator on it, and then you install the bracket back. So it is pretty convenient in this way rather than trying to fit the entire radiator to screw on the case, whereby you might get some very hard to access areas. So yeah, so the workmanship for this particular bracket is really good for installing top radiators. Next up, I actually do a copper mod for my, okay, so the aspect ratio is a bit weird. Let me use media player and rotate it. Yep, so here I did a copper mod for my 7900 XTX. So in the previous video, I think I showed that I already used Kapton tape to insulate all the surrounding SMDs. Yep, so surrounding SMDs around the VRMs, basically around the VRAM chips, right? To make sure that even if the copper shims do slip out, that they don't contact any electrically conductive no chips or any parts that is electrically conductive, and to prevent shorts. So here, what I'm using, I believe, is I apply thermal paste to as a thermal interface material between the copper shims and my VRAM chips. So I use the Maxtor thermal paste. The paste I'm using, I don't know whether I'll show it on the video. It's MTP something something. All I know is that it's the Maxtor paste that is rated for 11 watts per metric Kelvin. And it's pretty highly rated thermal paste. It's pretty good, and I've used it for several of my GPUs, and it's been good so far. What's wrong? What's wrong with the video? Okay, it's buffering. Yep. So I apply thermal paste on both sides of the copper shims, and then place them evenly onto the VRAM chips. It is quite a messy process, which is why you see me using latex gloves, because thermal paste is pretty messy. When it get on the skin, it's pretty hard to remove. Like, you have to use isopropyl alcohol, and then when they get under your fingernails and in between the grooves of your fingerprints, they are pretty hard to remove. So I prefer to use gloves for this process. You can see I'm already making a mess with my gloves because thermal paste gets on my gloves, and my gloves touch the PCB. Then you can see thermal paste gets on there as well. So overall, a pretty messy process. Yeah, then now I remove the existing thermal pads from the cold plate. Yep, so for removing, I removed the thermal pads and I actually kept them, I believe. So the thermal pads actually came from Baiski, like when I purchased the water block itself. Okay, so in this case, I tried to reassemble it, and I think there was an issue with the screw holes. So let me fast forward a little bit. Yeah, so when I turn it around, I think one of the screw holes was blocked, and that means I have to open up again. And you can see the thermal paste makes it such that the copper shims sometimes stick to the top of the cold plate of the water block. So it's kind of a risk whereby if I leave it as it is, when I try to close the cold plate with the PCB, there might be some interference and the copper shims might not sit evenly. So in this case, I transfer all the copper shims onto the cold plate, and you can see it's quite a messy process. I think alternatively, I've seen from, I believe, what's the other YouTuber's name? Shanks or something like that, that he uses thermal putty instead. So thermal putty as a thermal interface material between the copper shims as well as the VRAM. I believe thermal putty is still messy, but not as messy as thermal paste. So a much better solution for that, because you do need some form of thermal interface material between the shims as well as the VRAM chips. Partially is done to ensure that the copper shims don't move around as you move your water block and your CPU around. So that's that. Okay, so my wire is in the way here. I don't know when I'll notice it. Yeah, so now I notice it, and I move the wire out of the way. Okay, so I'm placing the back plate onto my 7900 XTX PCB. Okay, there are a few screws that goes on beef to secure like the water block to the PCB before installing the back plate. So screw those in. Okay, so screw those in. So once those are in, and then I screw in the screws for the back plate. I believe the back plate comes with some thermal pads for the back of the PCB for the VRAM chips. Okay, and then that's installation done. So a clean GPU water block ready to be installed. Next. Okay, how many more videos is it? Okay, so I think that will be it for part 2, because I still have filling, like the filling part. Should I just go through it? Yeah, I think let's just go through it, a quick one, because I really want to end this series, don't want it to drag it on. Okay, so in this case, this is another lengthy video. So GPU is seated in, so you can see my GPU water block is in, CPU water block is in, the heat sinks are all in, the water pump combo reservoir is in as well. But as I realized, I actually have misplaced, I think my reservoir pump combo is kind of misplaced. So it's a little bit, the orientation of the bracket is a bit different than before. And because of that, my previously well measured lengths of pipes somehow doesn't match anymore. I don't know, for whatever reason. Like I've changed the orientation of like the CPU water block radiator a little bit, and then that means that the pipes are a little bit too long. So in this part of the video, I actually show how I shorten the pipe. So to shorten like hard tubes, right, acrylic hard tubes or PETG hard tubes, you need something like a cutting tool. So you can have a saw and a vise, but I found this tool on the AliExpress websites, and it is pretty convenient. Basically, it is a tool for cutting like acrylic pipes. There's a vise and there's a blade on this part. So there's a blade on this part, a circular blade, and then this here is also a blade, and it comes with a vise. So basically, you tighten the vise, so you screw it in a clockwise direction, so that will tighten the vise, and it clamps on to the acrylic pipe, and then you round it. So you just keep going in a circular motion like what I'm doing here, and you tighten it a little bit more for each round, and eventually it will cut through. So after cutting through, you need to use the beveling tool to bevel away the sharp edges of the hard tube, of the PETG hard tube pipe. So here so I bevel through, and then I install the rubber thingy. So there's like a rubber seal thingy before you screw in the fittings. So that is installation for the top. So this is for my output of my CPU water block into the input of the top radiator. In between, I have a digital flow meter, something like that. I also bought it from AliExpress. I think cost about $50 SGD or something like that. So it's really useful. It not only does it measure the flow rate of the coolant, it also measures the temperature of the coolant. So it's a thermometer and a flow meter as well. So it ensures that it kind of gives me a sanity check to ensure that my pump is working, because the digital flow meter will show that, okay, if my pump is working, then there's flow. So what is the flow rate? 2.5 liters per hour or 2.5 liters per minute or something like that. And then what is the temperature of the coolant as well. So it just, it's kind of like a safety feature to ensure that I don't switch off my pump. So this part, there's nothing. Okay, I think I'm AFK, away from the computer. Yeah, so that is that. Because I did encounter an previous issue where I accidentally switched off my pump, because the pump comes with like a remote for LED and controlling like the pump speed and fan speed. Basically has that kind of fan controllers, and then I was messing around with my RGB lights, and then somehow or the other I happened to accidentally press upon certain combination of buttons that totally stopped the pump. So then the temperatures in my system was building up, and I didn't know why. So it took me a while to realize that, oh, my coolant is not flowing because I switched off the pump. And after I re-enabled the pump, I switched on the pump, then everything was normal again. So after that episode, I kind of invest in a flow meter to ensure that this kind of things don't happen again. Okay, so in this case, I think there was also an issue with this pipe. So you can see that this original pipe was supposed to fit well, but now with this new orientation of my pump reservoir combo, it is too long. So I'm gonna have to cut it as well. I think my video stops here. So I'm gonna show it on the next one. Yep. So in this next video, I actually shortened the pipe. I'm gonna speed it up to 4x again. Yep. So I finally noticed that it's too long, and I think so I did adjustments to my bracket for my pump reservoir combo first, because I think it is sitting too far in. So I wanted to bring out the reservoir a little bit further out, and that is a pretty tedious process because it involves needing to modify a few of the screws. I believe I removed the entire bracket, if I'm not wrong. Let me see, what did I do here? Yeah, so I kind of have to unscrew and remove the entire bracket from the fan. Oh, okay. I already adjusted it. So I think I already removed it and adjusted it, and then I reassemble it. So I reassemble this shows I'm screwing it in. So I reassemble the pump reservoir combo, and it is still too long. So yep. So I used the cutting tool, and you can see me like going around in circles to cut the hard tube. So if it's not enough, then you have to tighten it again and cut it off. Okay, then it fits. So then I use the beveling tool to bevel away the sharp edges of the hard tube. So you have to bevel both the internal and as well as the external sharp edges. So beveling takes a while. And I think I go to the basin and wash away the plastic shavings. So obviously when you bevel, there will be plastic shavings, and I don't want the plastic shavings to get into my custom loop and clog up the system. So I make sure that I flush away all the plastic shavings in a sink before I install my hard tube. Okay, so everything fits. Make sure you have the rubber seal in the fitting before you install the hard tube. And what else am I adjusting? The bracket? I'm not sure. My hair is blocking most of it. Oh, I think I'm fiddling with... What am I fiddling with? The wires, I think. Yeah, trying to get the wires to route through the back of the case. And yeah, I believe it is almost done. Okay, so I think just 2 more videos. So now I'm mixing the coolant. So we have a squeeze bottle here, and I'm just gonna speed it up again. So I'm using distilled water, and in this case, this is a red dye, like red coolant dye that I purchased from AliExpress as well. So basically, I'm gonna use, I think, the entire bottle. Their mixture ratio is indicated there. I think 1:25. So then I mix it with distilled water. Okay, and then coolant prepared. So I make sure I mixed it well. Alright, so we have red coolant for an pure AMD system, because I'm using an AMD CPU as well as GPU. Okay, next up, we have we'll try to top it up. So I'll try to top up the pump reservoir. This is where the squeeze bottle is really useful. You can see that my reservoir is in a place whereby the funnel can't even fit in. So I give up and just use the squeeze bottle directly. So the squeeze bottle comes with like a straw, a curving bendy straw that you can curve in. And I'll just speed this up again to maybe like 3x. So I do have this valve. Like this is a on-off valve that I use connect to the output of the pump reservoir combo. So I fill up the valve, I switch off the valve, I fill up the reservoir to a certain level, and then after that I switch on the valve and you can see the coolant filling in. So this one is the kind of the most satisfying process to see the GPU block being filled up with colored coolant. Here, I believe I have to fill up. I think I need to power on the system. So, before I elaborate, let's pause the video for a while. So here, I still have, I believe the 24-pin power cable is still not connected to the motherboard yet. I still have that plug whereby it kind of short circuits a 24-pin power cable so that I can power on the system, like power on the pump and the LED lights without, basically the pump. I can power on the pump without needing to power on the motherboard and the CPU, because the pump is connected to a fan controller, and the fan controller is directly connected to the power supply. So what the 24-pin plug does is that it short circuits a 24-pin plug so that you can power on the power supply without requiring the 24-pin power connector to be connected to your motherboard. So yeah, so let's see what happens. Okay, so here I power on. You can see that once I power on, it flushes, right? Oh, yeah. So once I power on, the pump activates and it, yeah, pushes the coolant into the rest of the system. So we have to repeat the process, because once I switch it off, the coolant will backflow. So I have to fill up the reservoir again, and then I have to power cycle again to get the pump to push the fluid through, and then do the same thing. It will backflow again, and I believe I need to keep the system powered on while I fill up the coolant. Okay, so I think I filled up until this level, and then I realized that, okay, it's always going to backflow, so I have to keep the system powered on. So here I keep the system powered on, and now I have to, okay, it will backflow. Okay, I realized that I actually connected the tubes in the wrong order. Yep, so the mistake I made here was that the output of my side radiator into my pump reservoir actually needs to have this like extension hard tube. So the extension hard tube will make sure that the coolant goes into the fluid, and that prevents it from sucking in air back in to backflow into the radiators and the pipes. Because if you suck in air, then that introduces air bubbles in the system, and your water cooling system will not be as efficient. So you want to prevent that, to make sure that if there's any backflow, it's sucking in fluid, coolant, and not air. Yep, so in this case, I made some adjustments to the hard tube of that casing, of the coolant reservoir casing. And then now, as you can see, oh no, what did I just do? What did I just do? Okay, let me pause here. And now, as you can see, there's this hard tube that's connected to the exit from the exit pipe from the side radiator. So this hard tube here, acts something like a straw. So it lowers, so it makes sure that the output of the radiator goes into the fluid. So once you have your fluid filled up to here, even if any backflow occurs after you switch off the system, it will be drawing in fluid instead of air. So that minimizes the risk of having air bubbles to be backflowed back into the custom cooling loop. So here I leave the system on, and you can see that the water keeps going in. So this amount of fluid, right, is not enough. You can see that the water level is here in the reservoir, and the output of the pipe is here in this level. So if I were to switch off the system right now, what happens is that air will be sucked in, and air will go back into the system through here. And yeah, that would introduce air bubbles in the system again. So you need to have the reservoir to be filled up high enough such that the water level in the reservoir must be above this intake, or no, so above the where the coolant comes back into the reservoir, the water level has to be above it. So that, as I mentioned earlier, so that you don't introduce air bubbles back into your cooling system. So here I'm topping up my flow bottle with more distilled water because I need to, I need to introduce more water into the loop. Okay, so I'm trying my best to top up more distilled water. We're almost there. Okay, so we have almost, the reservoir is almost filled to the brim. So I screw in the top cover of the reservoir, and I'm gonna begin tilting the system to remove air bubbles. So tilting is important because the air bubbles will tend to accumulate at the top part of the system. So in this case, there's a radiator at the top. Let me pause the video here. So there's a radiator at the top, right? So the air bubbles will accumulate at the highest point because air is the lightest. In terms of density, air is lighter than fluid, than water, so it will flow to the top. So you want to try and remove the air bubbles here by doing the tilting method, and you tilt the system around to try and get the air bubbles to flow around the radiator, to flow to the exit of the radiator, so that the fluid can push out the air bubbles there. Yep, you can see the air bubbles exiting from the system here. Yep. So as I tilt, you will see the air bubbles coming out here. Then obviously you have to release the valve to let the air escape from the reservoir. Make sure that the reservoir is watertight, but usually it comes with like a gas release valve, which I did invest in. So the gas will be able to escape through the valve here, but not the fluid. So I tilt the system further to remove more air bubbles. And basically the process is repeated. Okay, so I also tilt it front and back. Yep. So it takes a while for all of the air bubbles to be fully bled from the system. I think at least 2 days, I believe. Then I think something that I did not record after this video clip was that there was some slight leakage here. So here I will show cable management. So as I tilt, maybe here. So this is what wasn't shown in this video because it happened after the video was taken, was that I did not tighten this part and this, I believe the top part of the fittings properly, and there was actually a little bit of leakage because on, I think, the 3rd day or 4th day of using the system, I noticed that my fluid level fell to like here, and that is very unnatural. That is something that's wrong. Sorry, a burp there. So basically in the closed loop water system, if there's no leaks, right, the fluid should be going down a little bit. Like it should like go down by a few millimeters, like over the course of maybe a month or 2, because the water might, I don't know, like evaporate through in the reservoir, even though this, like, the water reservoir is not airtight, so air can escape from it, so water vapor can escape from it. So there is some minimal amounts of evaporation because it is mostly closed, but the evaporation still shouldn't drain the water to this level in like 3 days. So there was a leak there. So how I identified the leak was that it's nice to have colored coolant, because I noticed that there was red drops of fluid like here on the fan, and then here at the bottom here. And I believe there was some that leaked through the grills, because you can see that there are grills in here. It leaked through the grills and then it pooled behind, like on the below my PC case, like behind here. So it kind of gave me hints that there's definitely a big leakage because there's a pool of coolant that's outside of my PC case, but I had to identify where is it, and I, through using a torchlight and shine through, I noticed that there's no droplets here, thank goodness, because this is a CPU and this is the motherboard, this is the GPU here, and there's no drops of water here, so that means the GPU block is not leaking, so there's no water here. And I noticed that there are a little bit of red coolant here on the fans here, and I believe on the fans here. So it was a sign that the leak was from here. And then I also noticed that here it was not as tight as well. So after I tightened the two fittings, currently it's been about 2 weeks, and there hasn't been any further leakage. Like the water level in the reservoir has still stayed the same. So I believe I solved the leakage problem. So you got to take note that when you do custom water cooling loops like this, leakage is definitely a big issue. So I've seen some YouTubers, like I believe the Chinese PC building YouTubers, they actually use a sort of like a pressure pump. And I believe J2Sense has shown it as well, that you can purchase a kind of like a pressure pump from those online retailers, and basically it's before you fill up the loop with water, you want to pump air into it, make sure that everything is closed off tight, pump air into it, and see whether the pressure drops. If the pressure drops, it means there's a leak somewhere, and then you try to figure out where the leak is, tighten all the fittings, try and close off the leaks, and then try and do the pump again to make sure that there's no further leak. So here is basically just cable management, making sure that all my fan cables are powered, my fan controllers are powered, all the RGB cables are connected, and so on and so forth. Okay, so cable management is pretty boring and time intensive. So this is the part that I like the least about PC building, cable management. But a very nicely cable managed system is really nice to see because of all the work. Yeah, so you don't see ugly cables anywhere. Yep, so you can see the flow meter is in action here. Yep, so I believe the system is still not powered on yet. Yep, but the flow meter is connected, the lights for the GPU water block is connected, lights for the reservoir is connected to the fan controller. I believe the fan RGB as well as the water block RGB is connected to the motherboard. So the motherboard has to be powered on for their RGB to show. Okay, and then there is that. So I believe that should be the last video. And how does it look? No, these are my thumbnails. So the completed system basically looks like this. Wait, do I have it? Yeah, I have images of it. Okay, so completed system basically looks like this with RGB all on. So I'm using the Thermalright TL, I think C12C fans, 6 of them. This is actually, I positioned this as a intake because after I dismantled my previous loop, I noticed that there's a lot of air inside my case. So that means my PC case has negative air pressure, which actually meant that air was being taken in from all the vents here. Yeah, so negative air pressure, and which is why it was rather dusty. So I'm trying to make it a little bit more positive air pressure. So I have this two is intake, so these two fans are intake. This is intake as well, and then these 3 fans are exhaust, right? So I have 3 intake, 3 exhaust, but because there's a grill that is on top, because there's a heatsink on top of these 3 exhaust fans, so the airflow should be less. There's also a heatsink here for these 2 intake fans. The airflow is less as well, but this single fan at the back, I position it as intake, so to intake air into the system. Has doesn't have a heatsink between it, and there's a little bit of a grill, but it's not as obstructed. So I'm hoping that this will create a little bit more positive air pressure in my PC case and hopefully prevent dust from going into the system as much, into the case as much. Okay, so the flow meter here is in operation. This is the system fully power on. So there's RGB on the CPU water block. There's RGB for the 6 CPU fans. In this case, the RGB for the pump and the GPU block is not switched on, so you don't see the RGB there, but there is RGB available. Yep. So red coolant and on a black case. So I believe it still looks pretty nice. This is another view whereby it's shot from directly in front of the GPU water block, and you can see the reflection of light from the nickel plated aluminium of the GPU water block. So it's really nice. And maybe not. Yeah, is it nickel plated? It could be. I think it should be nickel plated aluminium. Yep, and that's that. So that's the completed system. Hope you guys enjoyed this and hope it's useful. Hope this is a useful reference video for anyone who is starting out with custom water cooling your loop. If you have any questions regarding custom water cooling, make sure to post in the comments. And if you like more content like this, please subscribe, and we'll see you guys in the next video.